Bismillahirrahmanirrahim. Today we start the characterization of the catalysts. Solid catalysts. Characterization of the heterogeneous catalysts. In heterogeneous catalysis, reaction takes place at the surface of the catalyst. As in heterogeneous catalysis, reaction takes place at the surface. Reaction takes place at the surface of the catalyst. So therefore, the surface characterization is very important. The characterizations is very important. As reaction takes place at the surface of the catalyst, therefore characterization is important. For characterization, different techniques are used. Different techniques are used. Those the, these techniques include the surface area and pore size analysis, surface area and pore size analysis, thermal techniques, and spectroscopic techniques. Spectroscopic techniques. These are commonly used techniques used for the characterization of the solid catalyst. So first we discuss the surface area and pore size analysis. Surface area and pore size analysis. As reaction takes place at the surface, so surface area affect the rate of reactions. As the reaction takes place at surface, so surface area of the catalyst greatly affect the rate of reactions. Greatly affect the rate of reactions. Surface area is one of the factors that affect the catalytic reactions. The activity of catalyst is properly expressed. The activity of catalyst can be properly expressed as rate of reactions per unit area of the catalyst. So in this way, the activity of different catalysts can be compared. The activity of different catalysts can be compared in this way. In this way. the activity can be expressed in terms of rate of reaction per unit area of the catalyst. And this property, Consi, the rate of reaction per unit area of the catalyst. This property can be used to compare the activities of different catalysts. There are two types of surface area. Two types of surface area in catalyst. One is called the outer surface area, outer or external surface area, that is the area of the particle, exposed particle surface, and the other is internal surface area. Internal surface area, this is related to pores, surface area of the pores. Surface area can be outer surface area or internal surface area. Outer surface area is related to the outer surface of the particles, while internal surface area, it is related to the surface area of the pores, the internal surface area of the pores. So the total surface area is of the catalyst is equal to outer surface area plus internal surface area. The ratio of the total surface area to the outer surface area, the ratio of total surface area to internal surface area to the outer surface area, is called the roughness factor. Ratio of the total surface area to the outer surface area is the roughness factor. Roughness factor is equal to total surface area and divided by outer surface area. So this surface roughness factor ranges from 1 to many thousands. ये minimum 1 है और higher maximum वो thousands में है. When roughness factor is 1, when roughness factor is 1, it means the catalyst particles are smooth in nature. Catalyst particles are smooth in nature. इस तरह spherical, non-porous है. Particles are non-porous. When roughness factor is high, means the particles are rough or the particles are porous. Particles are porous. A roughness factor is the ratio between the total surface area to the outer surface area. It ranges from 1 to many thousand. When roughness factor is low, it means the catalyst particles are non-porous. The particles are smooth in nature. If roughness factor is higher, ये non-porous होंगे. Non-porous particles. और pores means there are pores होंगे there. Particles are porous. Different types के pores होंगे. So this is outer surface area. And this is internal surface area. Particles can be either porous or non-porous. In case of porous, the surface area, total surface area would be very high. As rate of reaction is proportional to surface area, therefore high surface area is desirable. As rate of reaction is proportional to surface area of the catalyst. Therefore, a high surface area is desirable. जिस catalyst particles जिस catalyst का surface area higher होगा, that catalyst is more active. So this surface area can be increased and catalyst can be activated, can become more effective by increasing the surface area. So surface area can be increased by number one, decreasing the particle size. And second, making the particles porous, increasing the porosity. So surface area can be increased either by decreasing the particle size. जब particle size को decrease करते हैं तो surface area increases. So decreasing the particle size, the surface area increases. Or increasing the porosity. अब इस केस में देख लें, ये non porous है तो इसका सिर्फ ये outer surface area है. इस केस में वो outer तो है ही, लेकिन इसके साथ ये pores के walls जो ये extra surface area आएगा. So, increasing the porosity, making the particles porous, the surface area can be increased. Very fine particles have higher surface area. जितने particle size कम होंगे, however, very fine particle size is not useful in catalysis. However, very fine particles size is not useful in catalysis. किस वजह से? Because the fine particles pack up easily, so the surface area becomes non-available. Hence, surface area is not available. तो दूसरा फिर क्या ऑप्शन है? Increasing the porosity. So increase of surface area by porosity is useful. Increase of surface area by porosity is useful. Pores creates करते हैं, particles में particles को rough कर देते हैं, यानी pores उसमें creates करते हैं. Pores are classified into 3 types. Catalyst में 3 किस्म के pores हो सकते हैं. Pores, these are of 3 types, can be classified into 3 types. One is called micropores. These are the pores having diameter less than 2 nanometers. Pores having diameter less than 2 nanometer. एक है mesopores. जिस कैटलिस्ट में माइक्रोपोर्स होंगे that is called microporous catalyst. और माइक्रोपोर्स कौन से हैं? Having diameter less than 2 nanometer. और एक है mesopores. Mesopores are pores having diameter between 2 and 50. 2 to 50 nanometer. So if the diameter of the pores, most of the pores is 2 to 50 nanometer, those pores are called mesopores, and the catalyst can be called as mesoporous catalyst. And the third one is the macropores. These are the pores having diameter greater than 50 nanometer. Greater than 50 nanometer. So surface area, it is related to pore volume. The internal surface area or surface area is related to pore volume or pore size or pore radius. So if volume of the pore is, वो related किस तरह है? Mathematical relationship है. Let's suppose if volume of pore is Vp and radius of pore is R, then the surface area for a cylindrical pore is related to volume is surface area of a spherical are cylindrical pore is related to pore volume as surface area of the pore is related to pore volume as 2 Vp divided by R, where Vp is the volume of the pore and R is the radius of the pore. ये किस तरह रिलेटेड हैं? स्फेरिकल फोर्स या सिलेंड्रिकल, ये इस तरह है. ये लेट्स सपोज ये सिलेंड्रिकल फोर्स है, तो इसका रेडियस, ये रेडियस है R, और इस पोर का लेंथ वो है L. This is L length. So the volume of this pore, volume of pore या volume of this cylinder वो किसके बराबर है? pi r square into L, cross sectional area into length, cross sectional area और into length, ये वॉल्यूम है. और क्रॉस सेक्शनल एरिया किसके बराबर है? क्रॉस सेक्शनल एरिया इज इक्वल टू पाई आर स्क्वायर और लेंथ है आर. सो दिस इज वीपी. इसी तरह सरफेस एरिया, इस पोर का सरफेस एरिया क्या होगा? सरफेस एरिया वो है सरकमफ्रेंस एंड length, circumference into length. अब circumference किसके बराबर है? Circumference is equal to 2 pi RL, 2 pi RL, and 2 pi R circumference है और length ये है. 2 pi R is the circumference and length. So 2 pi RL. अब इन दोनों का रेशो क्या है? सरफेस एरिया डिवाइडेड बाय वॉल्यूम. ये हो गया सरफेस एरिया. So ratio in the surface area by volume of the pore. Surface area है 2 pi RL, 2 pi RL, और वॉल्यूम कितना है? pi r square L, pi r square L. तो pi कैंसिल आउट, L कैंसिल आउट और R इसके साथ कैंसिल. तो सरफेस एरिया इज इक्वल टू, ये VP को इधर लेते हैं तो 2 VP डिवाइडेड बाय R. तो सरफेस एरिया इज रिलेटेड टू द साइज ऑफ द पोर. साइज को कम करते हैं तो सरफेस एरिया इंक्रीजेस फॉर सिलेंड्रिकल पोर्स. Radius of the surface, radius of the pores, if it is increased, यानी माइक्रोपोरस उसका रेडियस कम होगा तो उसकी वजह से सरफेस एरिया ज्यादा होगा. मैक्रोपोरस उसका रेडियस हायर है तो मैक्रोपोरस जो पार्टिकल्स होंगे उसका सरफेस एरिया कम होगा. इसी तरह अगर स्क्वायर पोर्स हो तो फिर क्या होगा? इसमें ए और ये एल है स्क्वायर पोर्स. तो स्क्वायर पोर्स के लिए वॉल्यूम ऑफ द पोर वो क्या है? क्रॉस सेक्शनल एरिया इंटू लेंथ। तो क्रॉस सेक्शनल एरिया क्या है इसका? क्रॉस सेक्शनल एरिया है ए स्क्वायर, ए इंटू ए स्क्वायर, और क्रॉस सेक्शनल एरिया को लेंथ से मल्टीप्लाई करेंगे तो वॉल्यूम बन जाएगा ए स्क्वायर इंटू लेंथ। और सरफेस एरिया ऑफ द पोर, अब एक साइड का एरिया है, यानी एरिया किसके बराबर है? विड्थ इंटू लेंथ। फॉर एग्जाम्पल ये लेते हैं, ये ए है और ये एल है, तो ए इंटू एल इज एरिया। अब ऐसे साइड इसमें 4 है, ये एक साइड ए इंटू एल, ये दूसरा साइड है, और एक ये हो जाएगा और एक ये हो जाएगा। तो ए इंटू एल एक साइड का, तो टोटल हो जाएगा 4a ये होगा 4al। तो रेशो सरफेस एरिया डिवाइडेड बाय BP is equal to 4al divided by a square l। l खत्म हो जाएगा, a e भी खत्म हो जाएगा, तो सरफेस एरिया इज इक्वल टू 4 वॉल्यूम एंड a। So it shows that surface area is related to size of the pores। इसी तरह रेक्टेंगल के लिए अगर पोर इस तरह के हैं, ये ए है, ये बी है, और ये फॉर एग्जांपल ये लेंथ है, तो ये आप खुद कैलकुलेट कर लें। देखिए इसके लिए सरफेस एरिया साइज के साथ किस तरह रिलेटेड है। अच्छा, अब चलते हैं कि किस तरह सरफेस एरिया, हाउ टू डिटरमिन द सरफेस एरिया, वो हमारा नेक्स्ट टॉपिक हो जाएगा।